Okay, today I was going to work some of the questions that the students in class asked on 5.6. Wanted to work them out here so you could see them worked out. I will be posting the answers to 5.6 probably early next week so you can check your answers with those. The first one is 71, the sine of 67.5. Now this is a half angle unit. It's pretty obvious to me this would be a half angle problem because of the 0.5. You know, we always try to look at these and come up with two angles we know. Well, we don't have two angles that we could combine and get a 0.5. So what I want to think is, what is that half of? Well, if we double that, 67.5 is half of 135. So let's think of it that way. Well, now that's a half angle. So we look at our identity sheet. We want to look for the half angle for sine. Well, the half angle for sine looks like that. So we're going to take that identity. So plus or minus the square root of 1 minus cosine A over 2. Here, since we have a 135 here, our A is 135. So when we write that out, we're going to say, okay, that's the identity says plus or minus the square root of 1 minus cosine A. Again, A is 135. All over 2. Now, since our original angle is 67.5, that's in the first quadrant, so we know our sine should be positive, so I don't have to worry about the negative here. Well, now 135, if we draw that, we draw a triangle for that, 135, if we draw that, that's going to be in the second quadrant. So we go around 135 is over here somewhere, so that's 135. 135 to 180 is 45, so our reference angle is 45. So it worked out because that's an angle we know. So we can fill in the sides, 1, negative 1, radical 2. So using that, the cosine would be adjacent over hypotenuse. So now we have the square root of 1 minus, that's going to be a negative 1 over radical 2, all over 2. So from our drawing, we knew the cosine of 135 was a negative 1 over radical 2, so we substitute that in. Now the rest of this is just fraction work. On the top here, first minus and minus is going to be plus a plus. If we think of 1 as radical 2 over 2, the top becomes radical 2 over 2 plus 1 over radical 2 is radical 2 plus 1 all over radical 2. And we still have that 2 from the bottom. Well, now, remember fractions like that, we take the top times the reciprocal of the bottom. Well, if we do that, radical 2 plus 1 times 1 is radical 2 plus 1, and the bottom is 2 radical 2. If you want to simplify it farther, you can, but it's fine like that. Okay. The next one is 73. Now here they give us this information, the cosine of x equals 1/4 and x is between 0 and pi over 2. We want to find the cosine of x over 2. So again, we go to our identity sheet and look up the cosine of x over 2. When you start any of these problems, if you're not looking at the identity sheet, you're cheating yourself. Look at the identity sheet. Well, it says the cosine of a over 2 is this, plus or minus the square root of 1 plus cosine a over 2. So we're going to put plus or minus the square root of 1 minus cosine x over 2. So we write out the identity. Now, for the plus or minus, they told us x was between 0 and pi over 2. We want x over 2. So let's take half of all those. Half of 0 is 0. Half of pi over 2 is pi over 4. So that means this angle x over 2 is between 0 and pi over 4. So that still puts it in quadrant 1. So we don't have to worry about the negative. Now we just substitute in. Here we have 1 minus, they told us the cosine of x is 1/4. Sorry, I copied that wrong. It should be 1 plus. See, I can't even copy the identity right. It should be 1 plus. Sorry about that. Yeah, the identity was 1 plus cosine x. I looked at the wrong one. It's 1 plus cosine x. So it looks like that. Now fractions on the top, 1 plus 1/4 is 5/4 over 2. Now if we take the top times the reciprocal of the bottom, we get the square root of 5/8. You can leave it like that. If you want to rationalize it, if any of you ended up with this for an answer, that's the same thing. Okay? 74 is similar to that. They gave us the sine of theta is 3/5. They told us theta is between 90 and 180. We're trying to find the tangent of theta over 2. So we look up the identities for tangent. Well, there's 3 of them. You could use any of them you wanted to. So you can use any of these 3. It makes no difference. Let's say I'm going to use this bottom one here. So 1 minus cosine A over sine A. So that's 1 minus cosine theta over sine theta. Well, now if we substitute in, we know the sine of theta is 3/5, so we can put that in. But we don't know the cosine, so let's graph it. Now they told us theta is between 90 and 180. We want theta over 2. So just like we did on the last one, let's divide all these by 2. That'll be theta over 2. 90 divided by 2 is 45. 180 divided by 2 is 90. So that tells us theta over 2 is between 45 and 90. Well, that puts it in quadrant 1. So let's draw it in quadrant 1. We know the sine is 3/5. That's opposite over hypotenuse. So the missing side, 25 minus 9 is 16. That'll be 4. So for up here, the cosine of theta will be adjacent over hypotenuse, 4/5. Well, 1 minus 4/5, that's 5/5 minus 4/5 is 1/5 over 3/5. If we take the top times, something wrong. Oh, I'm sorry, this is theta, not, doggone it. Sorry, I forgot, this is theta, not half theta. So we need to use the second quadrant. Messed that up there. I was looking at theta over 2 like we did here instead of theta. So we didn't need that. Theta's in the second quadrant, so I needed to draw that over here. So that'd be 3, 5, and negative 4. So this is 1 minus a negative 4/5. So 1 plus 4, that'd be 5/5 plus 4/5 is 9/5. Now if we take the top times the reciprocal of the bottom, we can divide top and bottom by 5. We can divide top and bottom by 3. We end up with 3 for an answer. Yeah, when I first started that one, I was carried away with what we did here, where we had to find the x over 2. Well, here we needed the cosine of theta. So theta was in quadrant 2. So I needed to draw it over here on this side. Hopefully that didn't get you too off track right there. So the next one let's do is 76. It's on the screen here. Now 76 says the square root of 1 plus cosine 165 over 1 minus cosine of 165. Now, again, first thing you should do is look at your identity sheet. We want to see if there's anything that looks like that. Is anything like the square root of 1 plus cosine over 1 minus cosine? Well, if you look at it, if I can get this all on the screen, do you see that these two look very similar? But if you notice the pluses and minuses, they're upside down. So it matches this identity if we flip it over, which means we take the reciprocal. So this identity equals the tangent of A over 2. So that means this one equals the reciprocal of the tangent of A over 2. So A is 165. You see that? So this is just flipped over from the identity. So it's just the same as the identity, except it's flipped over. So flipping over means take the reciprocal. So it looks like this. Well, the reciprocal of tangent we know is cotangent. So we can simplify that to cotangent. You can change this to 82.5 if you want, or you can leave it like that. Either way is fine. So that was a matter of looking at your identity sheet and look for something that matched. You see, it was close to match, except it was upside down. So upside down means the reciprocal. So we just did the reciprocal. Okay. The next one is 81. So 81, this kind of goes right along with 76. 81 says the cotangent squared of x over 2 equals 1 plus cosine x squared over sine squared. So the first thing I see here is half angle. Well, the problem is that's a cotangent, and we need, we don't have an identity for that, but we do have one for tangent. The next problem is, which one do we use? With tangent, we need to look at it. So let's look at the 3 for tangent and see which one looks best. Remember, comparing it to the other side. Remember, on verified problems, you always compare it to the other side. Well, it looks a lot like this second one. You see it, those look, remember, it looks like this one, only again, it's upside down. So here, this is cotangent. Well, we know cotangent is the reciprocal of tangent. So if we think of cotangent that way, well now, so we're looking for one of these tangent ones that if we flipped it over, took the reciprocal of it, it would match this. What do you see? That's this second one here. If you flipped it over, it matches. So if we take this one now, so if you wrote it all the way out, that'd be 1 over, well, that is the sine of a over 1, x over 1 plus cosine x all squared. So all we did was we put tangent squared here. Well, now if we square that and do the reciprocal is going to flip that over. So that puts 1 plus cosine x squared on top, and that puts the sine squared on the bottom. So now it matches. So again, you look at this as cotangent. Well, we can do the reciprocal for tangent. Then the only tricky part is which one to pick, because you want to match the other side. So we just picked one that would match the other side. All right, next one, let's look at 82. 82 has the sine of 2x over 2 sine x equals cosine squared x over 2 minus sine. Sorry, help if I write this so you can see it. Sine squared x over 2. Now when I look at this, I see two things. I see a 2x, that tells me double angle. And I see x over 2, that tells me half angle. So I'm going to look at my sheet. Well, the sine of 2x, if we look at identity sheet, the sine of 2x is 2 sine a cosine a. So we're going to use that here for the top. So that top becomes 2 sine x cosine x. The bottom stays the same. So we used our double angle identity. Now if we simplify that, well, I can divide top and bottom by 2. I can divide top and bottom by sine x. That leaves me with just cosine x. On the right side, we're going to stop here because that's as simple as we can go. So now let's go over to the right side. Well, we mentioned those were half angles. Well, let's look at our half angle identities. The cosine of x over 2. Well, the cosine of a over 2 looks like that. The square root of 1 plus cosine a over 2, well, we're going to square it. Well, that's handy because that's just going to get rid of the square root. So if we use that identity, this becomes 1 plus cosine x all over 2. Do the same with sine. Let's look up sine. It's this square root. So if we square that, that's going to get rid of the square root. So we're subtracting. That's be 1 minus cosine x over 2. Well, here we're subtracting two fractions. All we need is a common denominator. Well, they already have that as 2, so we subtract. 1 minus 1 is 0. Cosine x minus a negative cosine x is 2 cosine x over 2. Well, now we can divide top and bottom by 2, and we just end up with cosine x, and we're verified. All right. Now let's look at 83. 83 is another verified problem. The tangent of theta over 2 equals cosecant theta minus cotangent theta. So I see a half angle. So that's the first thing I'm going to look at, my half angles. The only problem is with tangent, there's 3 of them. How do we know which one to use? Well, if you look at all 3 of them, like this one has cosine in it, this one has sine and cosine, this one has sine and cosine. So if we want these 2 sides to match, if this side's going to eventually be sines and cosine, this side better be too. So let's see what we can do about that. Well, we know cosecant is the reciprocal of sine, so we can replace cosecant with 1 over the sine. Oops. We know cotangent, one of our quotient identities, that's cosine theta over sine theta. Well, here we have a common denominator, so we can subtract these. So on the top, you'll have 1 minus cosine theta, and the bottom, you'll have sine theta. Well, now let's look at our identity sheet. Which one do we want to pick? Which one looks like 1 minus cosine over sine? Well, that third one looks exactly right. 1 minus cosine over sine. So this tangent of theta over 2, we can replace that with 1 minus cosine theta over sine theta. And our 2 sides match and we're verified. So that's some problems we worked in the class on 5.6.